Thanks, Mario. It's really good that you guys attended Nicolas' talk before, because many of the things I'm going to cover during this talk, they touch, basically they cover things which Nicolas talked about Burp. Basically my talk is about releasing a new Burp extension, and as you can see, Nicolas was showing how powerful is Burp. And the intent of this presentation is to increase the way Web Proxy can see a web application when you do a web application security test. So before I get into the content of this talk, just a short introduction about myself. My name is Roberto Sgilibrani, and I like to find bugs. I like to break stuff. But this case is the first time I'm releasing something. I'm not a coder, so it's different talk from my side, and I hope you enjoyed. I've been speaking in other conferences in the past, Hack in the Box, DEF CON, other OWASP conferences. I lived in New Zealand for 7 years, and back then I founded the OWASP New Zealand chapter. And if you want to follow me on Twitter, I use Malrich as alias, and from time to time I publish my research into my blog. Okay, so the agenda for today is very simple. I'm going to discuss on some of the issues, challenges you have when you test a web application from the security point of view, what can be the solutions, and then presenting the new Burp extension, what it does, some 3 demos, and then some stories of how the extension can actually be helpful in real cases, scenarios, and then conclusions. So I don't like to write too much stuff in my slides, so the first slide is going to be just like this. And basically, it's just to keep things very simple and for you guys to follow better. So normally, when you test an application, you have your browser, your web proxy, and the web application, as you can see there. And this is the traditional testing approach, unless you're just clicking the button and scanning something. But normally, you should go through the web application, study the traffic, study what kind of technology is used by the web application, and look into your web proxy to see what it does and what's happening, where you can attack, where the entry points are. Now, in the last few years, there's been a lot of focus from the web proxy point of view technologies. And like Nicolas was explaining before, for instance, Burp comes with a suite with a lot of components, like the repeater, the intruder, the scanner, and other things. So these components, they are very, very cool, but the point is that they just talk to the web application. So they talk on considering the server-side aspect of the web application. They don't have any knowledge of what JavaScript is or what the DOM is. They are just looking to the web application, and they're actually, from the network point of view, they're just making the request to the web application and then doing something. So for instance, with the repeater, you take one request, you repeat it, and you get the response. That's it. You're not doing anything fancy with the web application itself. Now, I see this as a problem, especially nowadays, because there's been a lot of shift on the client-side technology. Think about HTML5, or think about web applications which make use of very complex JavaScript libraries, like jQuery. And if you have this kind of web application, like Ajax-based, where everything happens in one single page, like take Gmail, for instance, it's getting more complicated to test or approach testing of such applications with the web proxy, which is still relying on the old way. So it's still based the intelligence of the proxy itself to talk to server-side technology, but it doesn't take into account the client-side. And the other point which I want to make is that the web application, if you think about it, it's a very simple point, is not designed to be used by a web proxy. It's designed to be used by a user through the browser. So we are just man in the middle with the web proxy. But if the web proxy is not aware of client-side technologies, then we are going to miss stuff if we do evaluation of very complex web applications. So I asked myself this kind of question: how can we get the proxy to be close to the browser, or vice versa? Depends on which point of view you look at the question. And the answer is there. There are technologies which we can use together, we can combine to achieve a nice integration and to achieve more coverage when we do web application security testing. The response here is that we can use browser automation frameworks with the proxy APIs. So for instance, Nicolas was talking about the extender APIs, and some of the actually extension, they make use of these APIs. So you write your extension, and then with that extension, you can use some of the programming interfaces that Verb or other proxies like ZAP offers to a coder or a developer who wants to do more with the web proxy. So if we combine the two things together, I think we can actually make things easier for a security, well, for a penetration tester or someone making web application security assessments. So what do we achieve if we do that? So on the top, you see the traditional testing approach where we have the browser, web proxy, and web application. On the bottom, this is one I want to achieve. So you have the web proxy, which drives the browser. Then the browser goes through the proxy, and then the proxy connects back to the application. And I think this approach is the best to face with web application, which makes use of a lot of rich internet application, which makes use of a lot of client-side technologies. So on the browser automation option side, I looked into some options there, into some products, and there are very good technologies there which can be used. I don't know if you have heard about Seleniums or Crawljax or JUnit, or if you use these technologies, but Selenium basically is the browser automation framework, which I will cover more in depth in the next slide. Then Crawljax is a very cool Java application which is being designed to crawl Spider Ajax web applications. And then you have JUnit, which is the Java unit testing framework, which can be used with these technologies as well. On the Selenium side, there are different components. So the Selenium server basically acts as a server, and it's a central point. So it can drive the browsers, it can launch the browser, it can kill the browsers, and it supports this kind of language, which they call Selenese language, where you can put commands like, okay, go to this website, click on that link, fill like a form input field, and then click submit. You can build all this, and you can script it, you can pass it to the server, and then you have your automation going on. The very cool thing about Selenium is that you can scale it up. Basically, you have Selenium, what they call Selenium Grid, where basically you have a grid server and you have browsers which act as a nodes, and they can register to the grid and say, hey, I'm available. So just send me a command, and then I will execute it. So you have your script, whatever, Python or Java, which connects to the grid and say, hey, run these test cases. And all the browsers which have been registered into the grid will execute the test case. Then another component is the Selenium client-side WebDriver, which is very important. The most important thing to get from this slide is that Selenium has to have a way to pilot, to drive the browser. And the way it does it is through drivers. So there are drivers which make direct calls to the browsers to do things, to connect to the application. And for instance, you have, thanks to the drivers, you have support to multiple browsers like Chrome, Internet Explorer, Opera, even Android and iPhone browsers are supported as well. And this is another component which I will show in the demo later on. Selenium ID, which is like a Firefox add-on. So you can basically create test cases just using this add-on. And if you click record, you can record what you do in the context of the web application using your Firefox browser, which is very, very cool because it comes handy when you have a lot of sequence, well, a lot of steps to complete. Let's say you're testing a web application with a form which is like 9 steps. So you have to put first page, then submit, second page, submit, third page, submit, and so on. You can use this and you can script the entire form registration and then save it and export it as a test case. And that's where it comes JUnit handy as well, because the test case can be exported into different formats. And the format I'm going to use in the burp extension I'm releasing is JUnit, because you can export with JUnit and then import it into the extension. Okay, this is crawljax, which I mentioned before, and it's a very cool application. And the way what it's trying to attempt is trying to crawl Ajax web application. It's based on a white paper. It's very complicated, the mechanism and the algorithm which is behind. So I'm not digging into that. But this is a diagram I took from the white paper where basically what it does is going to go through the page, expath the page and the DOM of the page, and then it's going to take all references to the elements, and it's going to associate to each element some states. So it's like taking a picture of the DOM, and then for each state they're going to do action like click, move the mouse, or something else you will see in action. But this is the principle behind. And this is another diagram showing a little bit more what's going on. So you have a crawljax controller, which gets the updates from the Ajax engine on the right side. So if there's a click, that event will be recorded, sent to the crawljax controller, and then sent to the robot, which will reanalyze the DOM and see what has changed, and then take decision based on the changes which have been detected. So it's complicated, and the white paper, it's I think 200 pages, so it's not just that, it's just a few slides to give you just an introduction to what crawljax is. Okay, now coming back to the other side of the equation, what are my Web Proxy options? Burp extender APIs, these are very cool. I think this is the way to go with the API, because if you think about it, like Web Proxy itself is, to me, is that. I mean, it's a technology, you just man in the middle. The API allows basically to increase the longevity of Web Proxy technology. So that's why Burp, I think, and Zap are moving in that direction. With Burp, you can use, through the API, you can connect to some of the suites components, like the scanner, the repeater, the intruder, the proxy history, for instance, the session handling. With Zap API, more or less the same thing. You can have your, for instance, your Python script, which connects to the RESTful interface of Zap, and then say, okay, spider this website, and then collect all the URLs from the history. So you can do stuff. And they are really, really powerful things we can use all together. So from the benefits point of view, okay, some of you might say, okay, why you want to integrate this product with Burp? What's the end goal? Well, to me, crawljax represents the concept of augmented reality in the proxy. And it allows you to cover, like, and better spider complex web applications. And actually, I believe that the spidering intelligence of like Burp or Zap are not enough in some cases where you have rich internet applications. And in Zap, it has already been done. I don't know if you guys are familiar with Zap, but you can use the Ajax spider, which is crawljax, basically. And it will launch the browser and then crawl the website and then gather all the results in Zap. And this work was done by Guif Ruiz, a very nice work, because he had to recode some parts of crawljax to be integrated into Zap. So I want to do the same also for Burp. And yeah, what would be the benefit to use JUnit? Well, you can create test cases, you can repeat test cases, and that can help if you have really tedious web application testing where you have to do a lot of steps to achieve to a certain state. And JUnit is really the way to go, combined with Selenium ID. And the other point is that by integrating JUnit through the extension, you can leverage some of what Nicholas was discussing before about the Burp session handling rules and the macro. And I have a demo for that, which is going to show you a little bit better what this means. So how to combine all this, create an extension. You can grab it on GitHub. This is the URL for the source code. And as I said before, I'm not a coder. So, and me and myself and Java are not really good friends. I had to code this in Java, and it was really a nightmare, but I'm sure there are bugs, so feel free to come back to me if you try the extension and you find some bugs. Just email me or just send me a Twitter message. And this is the URL. So putting all together, this is how it works. You have the burp CSJ extension. This is the name of it. And basically, you can import JUnit test cases through Selenium IDE into the extension, and then the extension will call JUnit, and then JUnit will call Selenium WebDriver. Selenium WebDriver will call the browser that you choose in your test case, and then the browser will connect to the application. If you want to use crawljax, then you can use crawljax, and then the same will use Selenium, then call the browser, and then the browser will connect to the web application. This is just high level of what's behind all this. So what are the key features of the crawljax integration? So the first thing I want to make sure is to support the cookie jar, because I mean, if you have an application which requires login and you launch crawljax, it would just stop there on the first page if it doesn't have the right cookies to go through. So I made it in a way that it supports the cookie jar and burp, and then through the GUI, which you will see soon, you can click different things and you can change options. This is the first part of the GUI. I think that Nicholas was showing before. So you have control on which browser you want to launch with crawljax, how many instances of the browser, which is a very cool feature. And basically, you can have 2 or 3 instances of the browser launched to crawl faster the website. And the very cool thing is the crawljax share the workload across instances in a multi-thread way, and it's very cool. Then you can select your proxy type, so you want the browser spawned by crawljax to come back to your proxy, so you can see all the traffic that just be generated. If you want to use other browsers, as I mentioned before, you need to pass the driver location, and this is where you can pass the driver location of your Chrome browser or the Internet Explorer browser. All the drivers comes from the Selenium website, so you can download them, and you can just point it to where you save the executables. And this is the second part of the tab. The use burp cookie jar is pretty straightforward. Then you have other bunch of options which crawljax supports. So I made just the GUI interface to use those. And probably something useful is the exclusion list. So if you're logged inside the application, you want to avoid clicking log out or sign off or whatever. Or if you're an administrative interface, you don't want to delete stuff or change stuff. So you can put some keywords, and crawljax will not click on those links which have the keywords there. So there is a little bit of protection. And then you can control which elements it can interact with, like the A or button HTML elements, or you can be more specific, and you can select more than 2. The A and the button comes by default in crawljax. So if you notice a web application which has it's got a lot of events associated to TD elements or span or divs, then you can just click there, and then crawljax will do its logic against these HTML elements. The plugins you see there, it's called overview plugins. So when crawljax finish to crawl the website, it's going to generate a nice HTML report showing you all basically a representation of all the different pages you went through and all different statistics for each page. So I think now it's time for the first demo showing you how it works. Okay, here basically I'm just logging into this WordPress application. I'm just using my standard browser, Firefox. And this is to show you that you can use it in an authenticated part of the website. So this is burp, as you can see, as you saw from Nicolas' presentation. So this is the new interface if you load the extension, you will have 2 extra tabs. One is the crawljax. Here you control everything which is associated to crawljax. This is the option which, okay, if you, it's ticked by default because you might want to use that. So when I mean cookie jar is this part. When you cookie jar, it's the cookie jar that Burp has. That's why I logged with a browser before, so I could populate this table. And then you have all the other extra options which I showed you before. Sometimes you have to play a little bit. Sometimes you might have a go with crawljax, and it will end immediately. It will exhaust its logic. So you need to tweak a little bit the options there. That's why I put there a way for the user to choose what to do. Because if you don't have any control on the options, you might not use crawljax, which is a pity because it's really powerful. There you can choose the type of browser. Here you can choose the proxy. So this in this case I set on 8080, and this is the history. So the way to launch it's very easy. It's right-click and send URL to crawljax. So once you basically click there, then you will get an alert just to show you, okay, it's started. And now basically it's Burp, which is calling another browser. On the top, on the bottom, I don't know if you guys can all see, there is WebDriver written. Now I'm not controlling this browser. This is crawljax, which is automating stuff, and it's going through the website. It's using the Burp cookie jar to do its logic. So it will scroll down, clicks on elements, open new pages. At the same time, what it does, it's proxy through Burp, so I can see what it does. I can see the traffic it generates. And this helps Burp as well, because then if you put passive scanning, you get more information because the passive scanning applied to the traffic. You can see there is loading some pages. You will see more action. Now it's just reloading some page to begin, but it will click on the left side if he finds links on the left side. It will study variation of the DOM and then take decision based on what he sees. Here he was scrolling down, he went to this page. So it does it for you. So you can go and leave it there and go for a beer and then come back and see what it does, what it did. And this is all the traffic which has been generated by crawljax. I should have put the auto scroll trick of Nicholas here because I'm keeping going down. Thank you. When crawljax stops, finishes, you will get another alert saying finished, and you will get the reason why it has been finished. Here it's still going on, so it's still doing its stuff. You can set a limit of time of running, like by default it's 60 minutes. You might want to extend that based on the nature of the web application you're testing. But I think it's really cool because now you have a way to better interact with rich internet application, but you don't rely just on the proxy to do that. You rely on the browser, which is the way it should be done. Okay, back, I want to show you a second demo. And this time I'm going to use, it's a different technique. I'm not using the Firefox WebDriver, I'm using a remote WebDriver. A remote WebDriver, again, is part of Selenium suite. And basically, the way to set it up is a little bit different. Here I'm going through this website. I'm just logging into, just to populate again the cookie jar table in Burp. And I will be using Phantom.js. I don't know if you guys heard about Phantom.js, which is very cool software. And basically it's a headless browser, which supports WebKit. And basically you don't see the GUI. You launch Phantom.js, which I'm doing here, and we just go through the website. And since it supports the DOM and JavaScript, it's like a browser, but you don't see the GUI. And the very cool thing about Phantom.js is that it supports remote WebDriver mode, which is Ghost Driver, they call it. And here I'm just launching Phantom.js with the remote WebDriver on port 6666, and then I need to instruct Burp to connect to it. So here you can specify the URL, and then what Burp will do will connect to Phantom.js using the remote WebDriver, and then it will Phantom.js will then do all the logic of crawljacks into the website. So here I just started, and here you see this is the debug output of Burp creating a session in Phantom.js and say, hey, go here. This is the configuration that you have, and then go to this website and start your logic. Here you see the result of the proxy history. I need to put the render mode because you don't have a browser GUI. So the only way to show you here is through the proxy history that is doing its job. So it's populating, it's going through, it's generating traffic as it goes. And it's very cool because remote WebDriver means compatibility for all other browsers like Phantom.js, Opera, you have Android as well. Anything which supports remote WebDriver, you can use it in this way. And this is still going on. The cool thing here, which I want to show, is the target view and the spider. So what I mean for that is that if you put the website under the target view, you see hierarchy of how it's composed, the folders and the web pages. You can combine the two things. So you can use the spider there. It's a request queued 91 because it can see the traffic has been generated by Phantom.js. So it's populating Burp history, and Burp has got its own intelligence. So you can combine the two things. You can combine crawljacks with the spidering intelligence of Burp, and then see if you can achieve more coverage. And that's the case because I use it and I can see more coverage if I just use the spider in Burp. Okay, this was the second demo. Back to the presentation. So now let me talk about the second tab you saw before, which is the JUnit one. This is a beta at the moment. It works, but there are some, let's say, issue with the support for the Burp cookie jar. But I'll show you a way how to bypass that anyway. And basically, you can import. You use Selenium item. You import those into the extension, and then you can basically instruct Burp to call your JUnit test case. So this is the interface here. It's really simple. You can add the test cases, you can execute it from here, or you can register it. When I say register it, that means it's registered into Burp. And then from the session handling rules logic, you can invoke the test case. So here, this is a demo. This is a long demo, so actually, bear with me. Where is it? So here, this is a very simple website. It's like a demo for a shopping cart website. Okay. And I'm proxying everything through Burp. So this is some of the traffic which I generated previously. So now the shopping cart session has a cookie, of course, to identify what the user puts into the shopping cart, etc. What I want to do is to show you how you can use Selenium IDE in this case, what you can do. Now, Selenium IDE comes under the tools button, so you can invoke it from Firefox. This is a test case which I already done, recorded. Basically, what it does is just take one item and put it into the shopping cart automatically. And there you can see the commands which are passed through Selenium IDE to the browser. So when you execute, is basically calling the web page and adding the item there. It's simple as that. This is just to show you how it works. And here again, you can see the result of the traffic. This is the action of adding the item into the shopping cart. Now, the cool thing about Selenium IDE is that you can export that test case into what they call JUnit 4 WebDriver format. And when you do that, you can save it. Now, the part which I didn't do, that's why it's beta, is that you have to compile that Java test cases into a class. And then you can import the class into Burp. This is the source code of which has been generated by Selenium IDE. And you can see that it's calling a Firefox driver by default, but you can change that if you want. And this is the function in JUnit format which will do like, okay, call that page and then add the item and with all instruction to add the item into the shopping cart. And here I want to show you how you can basically, through Java, you can basically using JUnit to run that test cases, which is very simple. I'm showing you this part because then you can understand how the JUnit integration works on the background. Basically what it does is basically what you see from the command line. So I have to set the full class name, so I'm using test because test is the package, and add item 1, which is the class name. And I'm just showing this because if you're not used with Java, it's a nightmare to figure out how to invoke things. So here I'm just launching the same test case from the command line and it works. This is just to show you how it works. But when you import the JUnit test case, you just have to bear, well, keep in mind that you have to use the same syntax there when you pass it to the JUnit. And there is an example I put there. So this is the very simple interface. And when you basically add, you can see here you have to set the C folder, and then here you specify same package name dot class name. It's the only way you can pass it to JUnit to run it. And here you can add a description name, which can help you to identify what test case is. And that's useful when you register it, which I'll show you later on. Now I'm just executing the test case from Burp. And basically underneath is doing what I just showed you 2 seconds ago with the command line. It's calling JUnit, and then JUnit is calling Selenium WebDrivers, Selenium WebDriver calling Firefox, doing the test case. So now there are 2 items. The reason why there are 2 items is because I'm cheating a little bit. I'm setting the cookie there with Burp, because as I said before, the JUnit integration is beta, because I don't control the way the web driver is configured through JUnit. I can't pass the cookie there. So because it's compiled, and I import something which is compiled, and the web driver is already constructed by the JUnit test itself, I cannot add cookies to it. I don't have that control. So ideally, I should allow the user to import the source code, compile it, and then do the same thing. But before compiling, I can add my logic of supporting the cookie jar. So this is just cheating, like putting the same cookie to force the JUnit test cases to use it. And this is the result of the traffic which has been generated by the JUnit. So now you see there is a status button there that indicates if you register or not the extension, the test case. So when you register it, it will take some time, but what it does, it will add it to Burp. Then you can invoke it through the session handling rules. And this is the session handling rules view, which you saw also through Nicolas' talk. And here I'm just showing you how to create a new rule. And the trick here is to just simply use the invoke Burp extension function. And here, as you can see, the add item 1 is there, so you can invoke it. That's what registrations is useful for. Here I'm defining the scope of the rule, so I'm setting to repeater to any URL. So that means this rule is going to be used only by the repeaters component of Burp for any URLs. So this is the repeater, and I just took one request which clears the shopping cart. So now what it should be doing is that if you click the request, then it should call the JUnit test cases before and then do the request, because this is the rule I set in Burp. On the right side, I'm using the logger extension, which is very cool. It's showing you all each HTTP request made by each component in Burp, so you can differentiate if the request was from the proxy, from the repeater, from the scanner, or from other components. So now I set repeat, but you see below it's still waiting. It will not send a request till this is completed. So it will do its job, and since I'm forcing the cookie to be used, then everything remains within the same session. And then it will do the request. This is the way to integrate JUnit test cases with Burp session handling rules. And here you see from the logger view the output of doing this. Then you can take it to the next level. This is just very simple. You can create a macro, which after the macro has been executed, then calls the JUnit test cases. And then you can have multiple macros together, and then you can do your attack. And this is very useful if you, let's say, you have a complex web application, and you find, well, where there is you think there is a bug after 6 steps of something like a form. So now you can create a macro, which called JUnit test case, does the steps, and then you can do your attack. And then if you need to call something else after, you can. It depends how you configure everything through Burp. Why I've done this? Because for myself, it's really an advantage to integrate these kind of technologies, because you can speed up your testing, especially if you have to deal with very complex scenarios. And here I'm just creating some macros just to show you. This is the after extension, and the macro you create, they end there. So you can then invoke through that. And here again, you can follow what it does. Again, it will call, this time it will call JUnit test case and perform a GET request, because this is what I create into the macro editor. Okay, since I'm running a little bit out of time, this is just showing you all the macro. Okay, I'm coming back to my presentation. So what are the tips which some of the suggestions if you intend to use this extension? Well, as I said before, mix the Burp intelligence with crawljax, so like the Spider plus crawljax, not just use crawljax or not just use Spider, just combine the two things. When you create the JUnit test cases, be precise on what you do, because you might screw up with what you intend to do at the end. It's very easy that you are doing something and then you end up with a different result. So be careful the way you construct and you build your test case with Selenium IDE. And then, yes, if you're using JUnit, make sure you set the cookie. You have to force to set the cookie. I will hopefully release a new version soon which supports cookie jar with the JUnit integration. So now some stories back from my consultancy and penetration test I did in the past. I cannot name vendors or companies, but I can tell you, I can give you the situation which I faced and how this technology been useful. So there was this web application, and so I did my web application test, and I was in a phase of scanning it. And of course, the scan was with no results. There was nothing interesting. Then I launched crawljax, and what it found that it clicked on some elements which will basically have, there were pages which were base64 encoded. So that grabbed my attention. That's why you still need to have a manual approach and semi-automatic approach. So you need to see what is bringing you to you during the test. So I went there, and so I decoded the page content, and actually saw that the ping command output was there as part of that payload. That means that my Burp scanner was actually doing something. And since if you invoke the scanner, by default, it will try to do OS command injection, there was one part of the application where the output was base64 encoded, and Burp couldn't see it, so it couldn't find the reference to that. So to hit, the test failed, but in reality, the application was vulnerable. So yes, that was a command injection, which, thanks to using crawljax, which click on the element, then grabbed my attention to go that direction. It was a really complex application, really big. Another story. This application was making really heavy use of jQuery. So for each thing you were clicking, you were not clicking on really on the A element. You were clicking on diffs or span elements, and whenever you were clicking, you were invoking the toggle function. And then toggle function, we call something else, and then call a URL. So if you just leave burp spidering, I wouldn't get what will be the URL if you have clicked on that element. So again, if you use crawljax, then you will click on that element, and you will see where the URL will go. And one of the pages was vulnerable to process skipping. But normally, if you just rely on proxy technology, this kind of bug will be missed. This was a very cool bug. This small was internet banking application. And basically, you have to create a payee, and that requires 8 steps. And then if you have to do a money transfer to that payee, you have to do other 3 steps. Very complex application. And basically the trick was, okay, I want to send you 10,000 yen, okay, which is like 80 euros or something. So I spotted an attack scenario. Say, okay, what if I change the currency, right? It was possible to change the currency to euro. And I say, okay, I will do the attack. But before I have to do all these 11 steps, which was really annoying. So I used JUnit test cases to speed up things. And thanks to that, after some hours of testing, the good thing was that you could spend 10K of 10,000 yen on your side, but the other guy will receive 10,000 euro, which was a good deal. Because, yeah, 10,000 yen is 76 euro. Another bug, which that's why I made the example with the shopping cart, is that it was quite strange. There was a special product which was invisible to the user, like a product with an ID which you had to guess, basically. And that product, if it was in the shopping cart, it would decrease the amount of the shopping cart, the total amount of the shopping cart. But before to get there, you have to do so many requests, and it can only be applied if another item was in the shopping cart. It was kind of very difficult scenario to meet. And again, thanks to JUnit test cases, you can speed up things, and then you can concentrate more on the attack side rather than constructing the scenario to get you to the attacking point. So again, these are examples which I found useful and where you can find these bugs which are really, really difficult to find. So the future for this extension, I want to support more crawljax. Crawljax also supports plugins, which I forgot to mention. And basically you can write plugins with crawljax, and you can do other things on the top of that, which is really cool. And with JUnit, I need to make it in a different way, but still I want to bring this in. I want to show you this in this conference. Yeah, the support for the cookie jar would be good. So conclusion is, if you bring automation during your security testing, yes, you need to do some preparation. Especially if you're using JUnit test cases, you need to use those JUnit test cases. You need to create them. So you're investing a little bit of time before, but then you might get some nice return of interest after. Especially if you find very cool bugs, which you can show to your client or to your company. But yeah, it's not the ideal approach for people looking for quick wins. Like, okay, start, scan, okay, found, done. If you're really looking into the application, then you need to focus and then see if you can do more than just simply clicking stuff. And that's it. Thank you.